morning, ladies and gentlemen, and welcome to the Rutronik Connects webinar series. My name is Julian Klaus. I'm a corporate product manager here at Rutronik, and I'm your today's host of the Edge Impulse webinar. So, as you might know, we have a couple of webinar series going on since 1 or 2 months. So, in the first week, we had the topic of Wi-Fi. Then we had a complete week of cellular technologies. Now this week, we have some mixed wireless technologies like ultra-wideband, LoRa, and as said today, the machine learning. And in November, we will have the Bluetooth session. Wait a second. Today we have Edge Impulse in-house, and we will talk about the firmware development of our Nordic Edge machine learning devices. As said, my name is Julian Klaus, and today we have Wojcislaw from Edge Impulse in the house. Some practicalities before we start with Wojcislaw's presentation. The webinar will go round about 45 minutes to 1 hour, roughly. And for sure, you can always ask your questions. So we have in Teams here, we have the question and answer sector, and you can also post your questions anonymously if you want. We will read out the questions loudly at the end of the webinar, and Wojcislaw will try to answer your questions. If you have further questions after the webinar, for sure, you can always contact me or Wojcislaw after the webinar series. One more thing, the webinar will get recorded and we will post it on Rutronik's website to have a video on demand. So even if you are watching the video on demand afterwards, you can always contact us if you have any questions left. I would give the words to Wojcislaw. Maybe you can introduce yourself again, Wojcislaw.
Yeah, thank you, Klaus. Thank you all for being here. So my name is Wojcislaw Milivojevic. I'm currently an embedded engineer with Edge Impulse, where I work on building our SDK, integrating development boards, among others, Nordic development boards. And previous roles, I did a lot of development, hardware and embedded software on edge devices that are now scattered around the world in high volumes, and a lot of these devices were actually built on Nordic chipsets. So I'm quite familiar with a Nordic brand and Edge Impulse, where I work currently.
All right. So you can share your presentation if you want.
Yes.
All right.
Second. So share. Let me know if you see my slides in the right way.
It's in the web browser. You need to go into the presenter mode.
Let's do it again now.
Not probably. It's, I don't know. It's half the page.
Try again. Windows. This one. And share. No, not share, but slideshow. Now better.
Yeah, perfect. Now
okay.
It's working. Great.
Okay, so let's start from beginning.
Yes.
Again, thank you for coming, and this session will be essentially around firmware development for Nordic EdgeML devices. It will cover partially the what ML is, how it's combined with MCUs and this kind of processors that Nordic provides. What tooling do we have to do that in better way and easier way, and essentially at the end how we can build that into our application, being more firmware focused rather than some other way. I always like to start with this diagram. It's a very interesting one, showing what's traditional and what's, let's call it, new. This doesn't mean traditional is less better or new is much better, but it shows that things are changing and the old approach sometimes doesn't fit our needs, and we need to change the way we think. Currently, we always have this data and we think of the rules, and with that, we have outcomes, and then we iterate. Sometimes that's a tedious and hard process because it's hard for us to capture all these edge cases and understand our use case fully. So rules cover all the cases. But in this new way of thinking how artificial intelligence or edge machine learning approaches problem solving, it's much more natural to these kind of devices where we have data and outcomes, and then we make up the rules. So this iterative process is much easier for us and let's say for machine, so we get much better devices and much better user experience at the end. So how does this connect with Nordic and what Nordic builds? As we all know, Nordic Semiconductor is a chip company. It builds a lot of different chips, but it's very interesting how their chips are kind of good match for this EdgeML story and how they can enhance this user experience and in general make better products. So having that said, probably most of you are familiar with their offering, but they have now quite wide one. But currently and on today by presentation, we're going to focus on 52 series, 53 series, 70 and 91 series. Soon to be released 54 series as well. But my point is we're gonna focus on processing or MCU part of the portfolio. So their philosophy, as they state, and I agree with it, it's very focused on IoT devices and doing this edge ML. But their like main design philosophy being low power, high performance, secure, and ease of use are ones I agree with, especially with ease of use. Probably you all agree having this Zephyr path with nice tooling is very convenient way of building firmware, and I like that it's getting better by the day. So on top of this, which is offering that most of the MCU vendors do, what's something that can distinguish? What's something we can add or how to say add a new value so our product is much better than the rest? And that's always the question. So this is where maybe Edge AI comes handy. So benefits of the building and bringing Edge AI to our devices have many forms. I would say these are like the most basic, but the most impactful one, where I always like to emphasize energy efficiency, cost, and bandwidth and latency. So energy efficiency, we're going to talk about that a bit more in next few slides, and how using Edge AI helps us save that precious power, battery power that devices are usually running on. Cost is always, I think, connected to bandwidth and latency, especially bandwidth, because we don't have to send data maybe that often as we think we do. Reliability and privacy and innovation is always something that comes kind of natural with Edge AI. So yeah, energy efficiency, as I said, for me, that's always important one, being since I built devices that needs to run very remotely with very limited power sources, and we always have these two ways to go. So we have like a cloud computing and edge computing. In cloud computing, we aggregate data, collect them in some internal memory or whatever, or send them every time we gather them. But essentially, we're sending everything to the cloud. That knows to be power intensive. Again, we're going to see why. but all the computing is done in the cloud. And it's like offloading that computing somewhere else. On the other side, we have edge computing. So everything that we gathered is processed in the device itself, and that may be able to help us sending less often, or yeah, essentially saving power. That's my main point here. We can see that, for example, in this graph of one 24-byte data packet being sent over cellular, and see how much energy actually it takes. This is a specific case for NRF 9160 in Telenor network in Norway, but essentially we can take it as a rule of thumb. We have this huge overhead. So data usually is, in this case, for example, 3% of all things exchanged, 3% of all energy used to send 24 bytes of data. You can even see it a very, very thin line in this time series diagram is only data. Everything else is handshake and other things that needs to that network and device needs to exchange. So being that said, we can look at this interesting table and see that even if we reduce, and we tend to do that, we tend to compress our data, how we send data, what we include in that data. We tend to compress that, but actually that has quite a minimal impact on device power performance. We can see here, for example, sending 2048 bytes and sending 1 byte corresponds in like 0.4 milliamps of current. But if we do that every minute, but if we move to sending data much, less often, it is much better, since we can see how much how less power we use just that data being sent less often. So having that in mind, and if we translate that energy into power cycle, that energy into CPU cycles, and that energy into time, and how much time we need for sending data, and compare that to how much time we need to process even more complex models like image recognition or keyword recognition, we can see the increase in performance and saving of power in multiple how to say this, much bigger savings. So essentially for processing some gesture, we need 17 milliseconds, and we can say for sending data, we probably need few seconds or few tenths of seconds. So if we compare these, we can see how that correlates with power and how much power we actually save there. And that's all nice, but the key point here is that sometimes can be hard. And I like to show you here how we manage, we meaning Edge Impulse and Nordic, managed to make that easier for everyday developers, and especially firmware engineers and ML practitioners. So we created ML Studio. It's based on Edge Impulse tooling, and it's specifically designed to support all Nordic development boards and prototyping and production for development with Nordic chips. This studio supports, as I said, a wide range of Nordic products coming from 52 series, 53 series, and 91 series, which include 9161 and 9151 DKs that will be released soon, and in the future NRF 54 as well when it comes out. To show how this works, there is this nice diagram that actually shows one very important feature and thing that being building ML model or building firmware that includes ML is quite an iterative process. And to do that, you need to have tools that will support you in that journey. I always like to show this Thingy 53 device. It's a Nordic device, kind of a dev kit that's meant as a very nice starter if you want to even deploy, because it includes batteries, sensors, management of power, and all that you need in essentially edge device. With that, it comes the Edge Impulse Nordic application that includes many features that we're gonna talk today about. But each of these steps being collecting data, designing a model, testing model, and deploying a model is very important, and it's very nicely streamlined with what Nordic offers and what Edge Impulse offers with Nordic ML Studio. So first, whenever we want to build something, we need to collect data. And again, I'm gonna focus on Thingy 53 story. So having that device with the app enables you to collect data from many sensors it supports, or even connecting some other sensors that are not included. But essentially, this device includes an environmental sensor, color, and light sensor. Accelerometer, magnetometer, and microphone. You can directly from app select the category, even write what you're capturing. So maybe set some label, select the sensor, sample length, and even select the frequency which is supported for such sensor. Collecting that data enables you to build better models, and that is exactly the next step. So designing your model, I won't go into that because there are much better people who can explain that, and there are nice videos who can explain the model you need to build for your specific application. But essentially, it guides you in creating this low-code environment or no-code environment where you can put blocks, select what you need, and then train your model with that in mind, and have it optimized for RAM and ROM memory, and even latency performance. Then we come to testing. Here we showed a real-world testing, but before that, even you can do testing in the studio, meaning there's a part of the studio where you can easily run your model inference in the cloud and see if it's roughly something you need. After you have that sorted out, then it comes to real world performance. And again, this is something where Thingy 53 story with the corresponding Edge Impulse Nordic app works very nicely. And you can test it easily. So with just few clicks, you can deploy your current model to the device with the DFU process, and start inferencing and start gathering results and testing live. We kind of mentioned this deployment step, and that is always kind of a hard part now, being easier and easier with all the tools Nordic and Zephyr provide. But essentially, this application has integrated DFU process for Thingy 53, and it enables you to directly send the binary from the app to the device and upgrade the firmware. And now we come to the more interesting part, at least for me. So, okay, this is all nice. We have all these tools. It works very nicely together. It's very good for prototyping, for understanding an application, even for developing application. So you have this quick iterative process. But now I need something different. being said, I'm building a firmware. How to do that? Well, all the boards, including Thingy53, including 52 DKs, 53 DKs, and 91 DKs, come with their firmware that is open source and hosted on our GitHub. So you can see all the features it includes. It always includes sampling sensor running inference features. Sometimes you need that in your firmware, sometimes you don't. Inference, of course, but other features that are there are usually useful when getting started, and you can explore that through all these provided firmwares. And even this NRF Edge Impulse app is open source and hosted on the Nordic Semiconductor GitHub, so you can explore that and see how the protocol is working between the devices and how you can reuse that in your own applications. But it always, I like this question since it comes quite often. So, okay, this is all nice. I get a binary blob, but what am I going to do with that? I mean, I have my own firmware. I need my own model. So yeah, that's what this platform has in mind. So for running your firmware with the model and only with the model, and means that instead of selecting some other option in deployment, for example, specific board, you just want to select a C++ library as an output. You will get a zip that includes all the source and header files, include that in your app, and essentially you can easily run it. Adding few configurations. This SDK of ours is dependent on CPP, so you need to enable that. Maybe even enable floating point unit, and it comes down to easily running one function run classifier and providing it with all the parameters, so it can easily run your model and see the performance you have on device within your app. For that, I always like to show people this example standalone inferencing for Zephyr, for example, which is quite a neat app because it is very, very small. It shows exactly this, how I run my model on Zephyr Nordic devices. Not having this other stuff we include usually in other applications that we build that you can provide directly from the studio. So at the end, it's very simple. So you use your favorite West command, as I say, West build for your specific board, and in some sort of logging, being that UART or anything else, you can get the results. My model usually always runs, my default model usually runs this classification for with accelerometer, being showing that device is idle, moving in a snake pattern up and down or a wave, and I can even see anomaly if I select this to run with the model. That being said, I would like to conclude. This maybe wasn't that much technical, but if you have any technical questions, I'm here still. So yeah, let's discuss. And yeah, I hope you had a good time.
Thank you, Vyacheslav. Let me just enter my camera. So we already have some questions. So let me check. The first question is, does my microcontroller need a special hardware to run machine learning?
Yeah, that's a good question, and I think Nordic is a good example of showing that it actually doesn't. So Nordic has Nordic has a Cortex M4 and Cortex M33 cores, and it shows that it can easily run, especially the cores that have higher speeds, frequencies. It can easily run inferencing even for some image classification or keyword spotting models.
Okay. The next question is, can I train models on the device?
That's an interesting question because Currently, for some device, it is probably possible, but I don't think MCUs are focusing on that. And majority or most of the training for such edge cases is still done in cloud. And I think it will be still done in cloud. We can go back to the presentation, but I think you all remember that iterative process I gave. So the main goal device has is to run inference and still return results to the cloud, so that this process can be done over and over again, and model can become better and better over time. That's the main reason we have this feedback loop.
Okay. The next question is, what does it actually look like to run machine learning inference on a microcontroller from a point of the code?
Yeah, I think we had one slide showing that, but essentially having Edge Impulse SDK and with Nordic ML Studio, it means running essentially one function, calling the whole stack between it. Calling the whole stack that's behind it to work for you. Today, modern devices, I think it's very hard to build an IoT devices without real-time operating system, because we have a lot of these stacks that are very complex. If we look at Bluetooth, if we look at LTE, you can look at the ML in the same sense. So there is a whole stack supporting you behind that, and that's actively being developed, actively being tested. So you can be sure that something you bring into your application works well.
Okay. I see another question. Can the development models be updated on field? Is there any ref design or example?
Yeah, this is something we are working on intensively, because we see more and more, let's say, not problems, but people having issues creating that feedback loop. That's why one of our motives was for building this application. So, for example, for Bluetooth device, you have this very nice way that is open source for Thingy53. That means it runs on an NRF5340 MCU, and it connects with the Bluetooth. You can send data, you can see how data is sent, you can see how data is managed, you can see how inference is run, and you can see how the DFU process is done. And that DFU process, every time you want to do it, actually includes a new model. So in this way, you can see that for Bluetooth. For LTE, currently, we don't support out of the box, or we don't have an example for updating the model. I know Nordic does through their cloud, and essentially, I think it only means bringing your binary with the new model to the Nordic cloud, and then you have these mechanisms. So it's essentially there, but from Nordic tooling. If you look at these two examples Nordic provide with their wireless software.
Okay. And one question from me. So I saw on your slide you will support the NR54 820. Will you also support the L15 as well later on?
I thought it was there in the slide, but yes, for sure, okay. Both NR54 series.
All right. Okay. That's nice. Okay. So there's no more questions left, I can see. But if you have any questions later on, or as said, if you are watching the video on demand, you can always get in contact with us, check out our website, our social media, or of course you can contact me directly, or Władysław. You had the contact information on the previous slides as well. Again, you can also contact via the QR codes you can see on the right-hand side. And one more thing to mention is that We also have one more webinar today with Yageo for the antennas. And if you are interested into the last webinar series, which is starting at November 4th, with the topic of Bluetooth, you can also check out the QR code on the right-hand side to register for a lot of new webinars in November. As I said, if you have any questions left, always feel free to contact us. And if you have no more questions left, then I wish you all a good day. And it's almost close to the weekend, so yeah, I can also wish you a nice weekend. Thank you. And thank you, Wojcislaw, for attending the presentation.
Yeah, I would like to thank Rutronik and Nordic for having us, and yeah, thank you for being such a good host.
All right, then good day. Bye-bye.
Bye.